Okay, so today our topics microprocessor 8086 microprocessor architecture or block diagram or internal diagram or similar one. Okay, architecture or block diagram or internal diagram of 8086 microprocessor. Okay, so all are at first you would go to first divide the middle position, this position. Okay, this is the drawing policy. Okay, at first this draw. Okay, all are draw this. Yeah, yeah, here at first draw this. Draw this position, this dot 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 middle of your notebook. Okay, this is the middle point, and also this the column, and this the row wise middle. The row wise middle this line not dot dot. This is the straight line. This straight line just small extra part. Okay, of another side. Okay, so this at first this dot dot dot, then this line. Okay, all are clear?
Yes, sir.
Finish these two lines, this line and this dot dot line. Okay, so our total part 1, 2, 3, and 4 part. Total 4 part. Okay, all are clear? So first part you are, all are draw this is the technique at first, this block. Okay, this technique at first. Suppose this. So at first this is the middle, then the middle, then also last middle, all are middle. Okay, so this is the total 8. Now 4 are half. Okay, clear? This. All are clear?
Yes, sir.
I guess, sir. I guess.
This draw policy. This draw policy total at first full part, then half. Okay, so now the draw finish. Okay, all are clear? This at first draw this block. Okay, then the half, then this half, then all are half. Okay, so this is the technique, and the last piece. Okay, all are clear?
Okay.
This is the four half, and this is the another 4 is free. Okay, so this part finish. Now this first part finish. Second part, at first draw this block. Okay, this one block. Then this the V, sign V. Okay, under this block. Okay, side V, okay, and last, and this block, and last this block. These are 4 block. 1, 2, 3, 4. 1, 2, 3, 4. Okay, 1, 2, 3, 4. Okay, clear? So this block 1, 2, 3, 4. These are this one block. This is the V, then another block. This is the last block. Okay, so this is the 4th block. All are clear? Now
Yes, sir.
third. This the at first this like as reverse of V or like as A. Okay, here Then this block, this is the one block, total at first this block. Now this single 1, 2, 3, 4, 5. Total five is same size. Number 6 is biggest size. Number 6, this is the, okay. So this is the biggest. So all are same, small. Total 5. Then this is the biggest. Total 6. This total block is 6. This total block is 8. Okay. This total block 8 and this total block 6. Clear? Now this block same line of this point. Cover of this line. Okay. Small cover of this line and this line and this line same. This is the bus controller. Okay. And now this block is finished. Now under this block is total 6 points. This is the technique at first middle, then this part 3 and this part total 6. Okay, you are clear? So this your total block number. Okay, so this block 1, these are 8, divide 8 part, and this the another block, this second part, this is the 4th block, this is the 3rd part, this is the inverse of ALU, okay, and this is the like as A, okay, and this is the 6th part, 5 are same, and 1 is the biggest size, and same this the opposite right side same position. This is the bus control logic, and this the this position is under this position. This is the 6th block. Okay, so this is your total block name, the block diagram. Then the block name. Okay, now discuss block name. All are clear?
Yes, sir.
দেবা বুঝতে পারছো?
জি স্যার বুঝতে পারছি।
So now we are discuss this is the general register called general purpose register. General purpose register are 4. Okay, our this microprocessor 8086 microprocessor, you know that the 8086 microprocessor is 16-bit microprocessor. Okay, this is the 16-bit microprocessor. We already discussed this. Okay, this architecture, all register are 16-bit. All register. Okay, all register are 16-bit. All are clear?
Yes, sir.
Okay, now 16-bit means this the block is this block this suppose one register. So this register must be this the 16 position. Okay, must be 16 position. Total 16 position. This. Okay, this the 0, 1, 2, 3, 4, 5, dot, 0 to 50.
এত কিছু জানি না, তবে কুশের দাম হেতনাদের একদিন বাড়ে গেছে।
এই কি হলো তোমার?
I need to know, of course.
Okay, so this all register are 16-bit. This temporary register, this also 16-bit. This flag register also 16-bit. This CS register, this also 16-bit. Okay, all register are 16-bit. Clear? Now, this register 16-bit means this register means this the 0 to this position 0, this position last position is 15. So these are divides. So this position is 0 to 7, 8-bit. This is the 8-bit and this is the 8 to 15. This is the also 8-bit. Total this is the 0 to 15. Total is the 16. All are clear? 0 to 7, and now 8 to 15. This is the higher part, 8 bit, and this is the lower part, 8 bit. Total, this is the 16 bit. Okay, all are clear? Yeah, yeah.
Yes, sir. Yes, sir. Yes.
Now, our general purpose register use is the A, B, C, D. A, B, C, D. Clear? A means accumulator register. A means accumulator register. B means base register. C means counter register. D means data register. All are clear? Accumulator register, base register, counter register, data register. Yeah.
Okay, sir.
Clear this. So this accumulate these 4 register are 16 bit, but if you use, suppose we need the 16 bit data. Suppose we are using the assembly language program. This is the simple program, addition program. Suppose hexadecimal 19 plus A2. This is the addition. Okay. So this result 9 and 2. 11. 11 means B. And this also 1. This is the 10. 11, 12 means C. So your result CB. All are clear this? This is the hexadecimal addition.
Yes, sir. Yes, sir.
Already close our previous semester, digital electronics. Okay. So this all are clear? Deva, এটা কি বুঝতে পারছো? Abdulaziz,
Yes, sir.
clear this. This is the hexadecimal addition, simple addition. This hexadecimal one
Addition.
bit means
Yeah.
hexadecimal one bit means binary, 4 bit. This 19 means binary 0001, and 9 means 1001. Okay, this 19. And
Yes,
A2,
that is
A
one.
means 10, A means 1010, and 2 means 20010. So this is the 8-bit binary, this also 8-bit binary. Okay, convert the hexadecimal. Okay, all are clear?
Yes.
Now suppose this addition we are using this assembly language code. Now we are use at first code MOV, move means movement, just transfer. Okay, this is the short name MOV. Okay, this called mnemonics, assembly language code, this called mnemonics, short name. Okay, move short name MOV. So move, suppose this 19, this is the 8-bit. So if you use 8-bit, then N or A is no problem, BL or BA is no problem. This is the 8-bit data, this is the 8-bit data. Okay, 8-bit register, this is the also 8-bit register, different 8-bit register. But we use 16-bit, then name AX. Okay, so suppose now we use 8-bit, so this name, suppose we are data transfer L register, comma 19. Now L register our data is reserve 19. Okay, now suppose move BL register your data 8. Now your BL register data 8. Okay, just transfer this register. Now add AL comma BL. So this is the addition. This data, this A2 and A9 data, at first addition, then transfer L to BL register. Final data transfer this left side. Okay, so now your data is changed. 19 is changed. Now finally your data is this position. Result. And now your program finished. This called halt. H80 halt. So this your assembly language addition program. All are clear this program?
No, sir. Again.
Again, why?
Yeah. And you have to move add a little bit. Yeah. Okay.
This move means just data transfer. This data, 19 data transfer, 19 data transfer just this register, AL register. Suppose another program, this is the 16-bit program. Your program value 39 A0 and sorry A3 and 502B. This 3 and 4B. So this your addition. Okay, so these the 4-bit 1 2 3 4, and this the 4-bit hexadecimal. So 4-bit hexadecimal means binary 16-bit. Okay, so if you use this 16-bit data and this also 16-bit data, so now we not use AL AX, BL BH, CL CH, GH GL, not use. We are must be use AX, BX, CX and BX. Okay, because this is the 16-bit. If 16-bit, then name AX, BX, CX, DX. If 8-bit, then name AL or AX, BL or BH, CL or CX, DL or DX. So now our program, suppose this data transfer, move now AX comma 39 A3. So this 39A3 data transfer to our AX register. This full are reserved this position. Okay, this reserved position, this position your data 39A3. Okay, this full because we are use AX. Another move. Suppose we are use CX. So 502B. Now our CX data, this position, this 8, this now 16 bit, full position. Now this position your data, these are 502. So now this position and this position, this register and this register are addition or multiplication. Okay, multiplication means mul, M-U-L, multiply. Okay, or subtraction means, suppose you use subtraction, difference. So your code is SUB, sub. So sub x comma, sorry, x comma c, x comma c. Okay, now all. Okay, so this is the 16-bit program. Hold on. Right now, কি সমস্যা বলো, ক্লাস নিচ্ছি তো। তো তিনটা পর্যন্ত ক্লাস। Okay, so all are clear this? Yeah, here
Yes, sir.
is clear. If you use 16-bit, this data, 16-bit data, then we are use AX. If you use 8-bit, then BAs or BL, CAs or CL, AS or AL, no problem. These are 8-bit, 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 8-bit. If you use 8-bit, then 1, 2, 3, 4, 5, 6, 7, 8. Total 8 storage. But you use AX, BX, CX, DX, then your storage is 4. Okay? This is the storage. Clear? All are clear? So this is called general purpose register. This is called general purpose register. Now this two pointer register, indicate register, pointer. This name is stack pointer and this is the base pointer. Two pointer register. This is the 16-bit register. Stack pointer and base pointer. And these the two. These two is index register. This is the source index. Source index means where this data is coming, and destination index means where the position, location, destination position. Okay, this is the destination index. This is the index register. Okay, two index register. And this is the temporary register. Temporary register means temporary data transfer register. Okay. At first, all data storage, this is the temporary register, then temporary register to passing our ALU, arithmetic logic unit. Then this position is working the processing part. Okay. Arithmetic and logical processing part, ALU. And this is the flag register. This also another 16-bit register. Okay, flag register. Flag means this is the position indicate register. Suppose your result is negative, then this flag is one position. This total 16 position. This is the one position is the sign bit. If sign bit 1, then result is negative. If sign bit 0, then result is positive. Overflow flag. This another flag. If your data overflow, then this flag is high. This is called overflow flag. Okay, carry flag. Suppose your result is carry, then carry flag is also high. These are different name flag. I will discuss our next class. This is the flag register. Okay, all are clear? And this is the internal communication, internal control system. Internal control system, you know that our controlling part, ALU is the controlling part. This is the internal controlling system. All systems are controlling this position to this line to this connect. All are connected. This connected. This also connected. Okay. So this is the internal control system. This is the, you know that this is the ALU data bus. This is the data passing. You know that data passing is bidirectional, and this is the address. Okay, this is the unidirectional. This is also address is the unidirectional. Okay. So this part clear. Now these are address generation. This is a very important part. Address generation. Address generation means, you know that our register capacity 16-bit. Okay, Mithun?
Yes, sir. Yes, sir.
Our register capacity is 16-bit.
Yes, sir.
But you know that our address, this microprocessor, our address line 20. So address capacity, this suppose your memory location. This your memory location. Okay, internal memory location. Another, this not this register, this is the internal memory location. You know that this the 20-bit means our memory location 511 by hexadecimal means 4 binary. So 1, 2, 3, 4, 5. 5 hexadecimal. 5 hexadecimal means 20. 4 into 5. Okay. Any one digit means binary 4 digits. So 1, 2, 3, 4, 5. So this is the 5 address to last. This is the 0, 0, 0, 0, 1. Then 0, 0, 0, 0, 2. This is the hexadecimal. All are hexadecimal. Then last position is F, 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 F. Okay. This is your last position. So all location is 20 bit. 1, 2, 3, 4, 5. So 5 means 20-bit location. Okay, all are clear? Our internal register is 20-bit location, but our register capacity is 16-bit. And you know that I already declared our previous class this IP. IP means instruction pointer. It's what the next instruction preserved location creator. This is the location creator. IP is the important person. It's the location creator. Okay, where the data storage position. Okay, previously at first work IP, it's the generator the previous next data transmit location creator. So this not possible because this IP is 16-bit and our register is 20-bit. So how can possible 16-bit to 20-bit location? This possible. This capacity is 16-bit. So how can possible 16-bit to create 20-bit address? কি এই দেবা কি বুঝতে পারছো কথা? মিথুন?
Sir, capacity.
All register capacity is 16-bit.
Yes, sir.
But But our register capacity, memory location, sorry, address capacity 20 bit.
20 bit, sir.
Address capacity 20 bit, 1, 2, 3, 4, 5. So how can possible? IP is address creator, but IP, these are small size, this size is 16. How can possible IP is create the 20 bit location? Possible? This capacity 16 bit. It's not possible.
No, sir.
It's not possible the 20 bit. But this IP is help the CS, port segment. This is the 4th segment register. You know that we are already declared our 806 microprocessor are segment wise work. Okay, segment wise working. These are 4 segment register, 1, 2, 3, 4. This name is port segment, data segment, stack segment, and extra segment. Total 4 segment. Okay, port segment, data segment, stack segment, and extra segment. IP is help the port segment. Okay, port segment and IP both are working the part 16-bit address. These the both are 16-bit address, so both are combinedly working the create 20-bit location. This is the address generation. This position is address generation. Okay, all are clear? This is the 20-bit address. Generate the 20-bit address. All are clear? And this is the 16-bit data. This is the 16-bit. So 16-bit data no possible, but not must be possible because this is the 16-bit and data 16-bit. So no problem. But address 20-bit and this location or register is 16-bit. So not possible. One person is one word. So this IP is must be needed help. So this port segment is helping hand. This port segment and IP combinedly work than 16-bit to convert 20. Okay, all are clear? So this is the address generator, and we know that our segment register is 4. This is the port segment, data segment, stack segment, and extra segment. And this is the IP. IP already declared. IP how the what instruction pointer. IP means instruction pointer. Next instruction preserve location creator. Okay, and this is the internal communication register. This is the bus control logic. Our data bus, address bus, and control bus all are controlling the bus control logic. And this is the instruction queue. Total 6 queue. Queue means data pipeline. So suppose this is the one instruction, this another instruction, another instruction. These all are waiting. Okay, pipeline. All are waiting this. At first this transfer, then another waiting. These 6 are waiting. Waiting list. Okay, this called queue. Instruction queue. Okay, so this your architecture. Computer architecture. Okay, all are clear?
Yes.
Microprocessor architecture. Now your diagram finished. This is the arrow. Okay. These all are big. All parties described. Our next slide. This half. This dot. This your half column. This part name is bus interface unit. This part, this whole name is bus interface unit. Okay, and this whole unit name is execution unit. Okay, this name is execution unit. Execute part. These both are execute part, and these both are bus interface unit. And this all part is described. This is the segment, port segment, data segment, stack segment, extra segment, and this is the generator 20-bit address dedicated adder to generate 20-bit address, 16-bit to 20-bit address adder. Okay. This all segment register is described. Okay, this is the segment. Okay. So now all segment studies describe this port segment, data segment, plus segment, a stack segment and extra segment, total 4 segment. Use the instruction pointer, already discussed, use the instruction pointer. Okay, use the instruction queue, already declared, already discussed this part. Now execution unit. This is the ALU logic unit. This is the AXBX is CFP, the general purpose register, and this is a pointer, 2 pointer, base pointer, register pointer, and to the index register, source index and destination index. Okay. This same of 16-bit register can be named, if 16-bit register can be named AXBX, CXDX, and if 8-bit, then name AX or ABX or BX or CLBX or okay. We have the discuss execution unit register. So these all are studying this topics, okay? This 35 last that examinations. Okay, are clear?
Sir.
So
Yes, sir.
today our class is finished. Okay.
Yes, sir.
স্যার এই শীটটা দিবেন না?
Hello, sir.
এটা তো দেয়া আছে।
স্যার এটা তো আমি পেলাম না, আমি আর একটা পাইছি।
এটা দিছি তো মেসেঞ্জারে দিছি, হোয়াটসঅ্যাপে এই কোয়ালিটি দিছি।
Hello, sir.
Okay, so you are present this class. Last week.
Hello, sir.
Yes, sir.
Hello.
Hello. Yeah.
Sir, send PDF in a group.
It's not PDF. This is the PowerPoint.
Okay, send.
Okay,
Already
sir.
sent. Already sent this slide. এই পাঠাইছি না আমি মনির মিঠুন
জি স্যার
না তো ওটা ওদেরকে দিয়ে দিয়েছো ওটা আবার করছে না আচ্ছা 9 তারিখ
Yes, sir.
একটা সো দিয়ে আছে roll 2 absent no roll 2 present
2 আছে।
No, sir.
roll 3
Yes, sir.
মনির আছে roll 6 আছে
জি স্যার। স্যার
roll 8 is been like
রিসবি
9 10 আছে
জি স্যার।
10 আছে আর কত আছে 10 আছে 12 আছে
জি here roll number
14
14.
14 but why not use
12, sir. My controller.
submit to now
শুভন আছে স্যার। So 18 স্যার।
roll 9 option
রোল
Yes,
নাই
sir.
এখানে নাই।
নাই
total noise
Sir, 12, present 12.
okay so to the first